Welcome back to Chapter 9, and we're going to do a short lesson on a simple example of using depreciation. We're going to talk about the depreciation, which again is cost allocation, allocating the cost of a long-lived asset over its useful life, or over the period that we expect it to benefit us by helping us generate revenue. Now, our depreciation calculation, and again, this is talking about straight line depreciation, so it's probably the simplest example that we can use for depreciation. We start with the asset cost, and as we discussed in the previous lesson, our acquisition costs includes all reasonable and necessary costs incurred to get an asset ready for use in our business. So that's the amount that we start with, the asset cost. And this is a calculation. The first thing we do is subtract our salvage or residual value. We subtract our salvage or residual value. And keep in mind that salvage or residual value is an estimate. This is an amount that we expect this asset to be worth at the end of its useful life. And so, as you can tell, that's a future point in time, and so we really would have to estimate that amount. Although, you know, as we most businesses operate over the years using the same types of assets in their business, and so as time goes on and as we develop experience with different types of assets, how they're being used in our business, the conditions of use, you know, whether let's say if we're an excavator, if we're working on the east side of the island where there's a lot of dirt, as compared to maybe working on the west side of the island where there's a lot of rock, all of those things would affect how long we are able to use these assets and what these assets would be worth at the end of those periods. So again, we start with the asset cost and we subtract our estimate of salvage or residual value for that asset. And after we subtract this amount, what we end up with is what we can call net depreciable cost. This is the amount of our asset acquisition costs that we will actually depreciate or allocate to future periods of benefit. The next item would be our useful life, and this would be a division. Again, for straight line depreciation, we would divide net depreciable costs by our estimated useful life. And just as residual value or salvage value is an estimate, so is our useful life. And again, the same factors apply for salvage value. The more we use a particular type of asset and the more experience we develop with the various assets that we use, we can refine our estimates to make them more and more accurate over time. So we would divide this net depreciable cost by useful life, and the resulting calculation would be the amount of depreciation expense that we would record each period. And so, just to put some numbers to this example, let's say we have a $50,000 asset, and let's say our residual value is $5,000. So we would subtract the 5 from the 50, and that would give us net depreciable cost of $45,000. And let's say our useful life for this asset is 5 years. So we would divide 45,000 by 5, and the resulting calculation, 45 divided by 5 is $9,000. And so $9,000 would be the amount of depreciation that we recorded each year over the 5-year estimated useful life of this asset. The last thing I have here on the bottom of this sheet is a graphical representation of straight line depreciation. The reason we call straight line depreciation straight line is because when we graph it, and on this graph, on our vertical axis we have dollars, and on our horizontal axis we have time, or years in the case of the asset useful life. And so we can see that when we use straight line depreciation, the amount of depreciation each year is the same. And so when we connect those amounts from year to year, moving across the horizontal axis of the graph, it represents a straight line. And again, depreciation is cost allocation. So, we could show, if we wanted to, an estimate of the revenue stream that we expect to generate by having this asset. And so our revenue stream in this example would probably be very similar in terms of what it looks like on the graph. It would probably be very similar to our depreciation. So the idea is that if we have an asset that we expect will generate revenues for us in a stable manner, in other words, a steady stream of revenues without much fluctuation from year to year over the estimate of useful life of this asset, then straight line depreciation is an appropriate method of depreciation to use for that sort of asset. Again, we want to match the cost of an asset with its expected revenue stream over the period of time that we own and are using that asset in our business. If we were to take a look at the text where it discusses depreciation, on page 411, at the top right hand corner of the page, they also show a graph of units of production depreciation. And let me just put that in small here. The units of production depreciation depicted in the graph on page 411 looks like this. And we'll talk about units of production in an exercise in another lesson. If we are using a depreciation method like units of production, then the amount of depreciation for this asset, whatever the asset is that we are depreciating, will increase or decrease relative to the production of that asset. So as an asset is used more and production goes up, the depreciation expense would go up. And as an asset is used less and production would thus go down or decrease, then the amount of depreciation recorded for that asset would likewise decrease. And again, considering the matching principle, the idea is that for this type of asset, let's say we're using it to produce product that we are selling. As production goes up, our revenues generated from the sale of that product would be expected to increase. And as production went down, then the revenues generated from the sale of our production of that product would likewise tend to decrease. So again, we try to use the depreciation method, the type of depreciation that best affects the matching principle. Matching tells us that we need to match the cost of revenues with those related revenues in the same time periods. So revenues go up, the related costs would tend to also go up, and as revenues go down, those related costs would likewise tend to decrease as well. I hope this makes sense. We'll come back to some examples in some exercises, and hopefully that'll make it clearer. Thank you.